And incoming with me now, we have Dr. Nick Castle, a research scientist at the Planetary Science Institute. Uh, and you have changed the world that hovers behind you.
Yeah, you invited me to talk a little bit about Mercury, so I thought it seemed only appropriate to not have Mars glaring over my shoulder.
I do think that makes sense. And as we pointed out before, your username in the CosmoQuest Discord community is Mercurial Martian. You do pay allegiance to two different worlds.
Really, about 8 or 20 of them. Go figure.
So Mercury is a world that is way weirder than any of us ever imagined.
Oh, yes.
Give
Before we
us the
went,
411 on this little tiny planet.
so I'm only just recently learning about Mercury myself, so my apologies if I make mistakes. Please, if there are scientists that study Mercury in detail and have for years, don't yell at me. Anyway, we made a bunch of predictions about what Mercury would look like before we sent spacecraft to visit, specifically the Messenger spacecraft. And we kind of figured there'd be a lot like the moon. That is an airless body that had a plagioclase crust. That's a particular mineral that floats if you have a big molten lava lake. And so we thought that that would be what we would see. We also knew it has a very large core, which should mean that there's a lot more iron. So we'd actually expected the surface to have a lot of iron because, well, how else are you going to get a massive core? And it turns out we were wrong in so many ways.
Oh no.
So it turns out we can't detect plagioclase on the surface at all. This mineral that makes the bright spots all over the moon, we don't see it on Mercury. Now,
Oh
to be
no.
fair, it might be there because the spectroscopy we use to figure out what minerals are on the surface is flat and dark all over Mercury. So we can't tell at all what minerals are all over Mercury.
Oh
The other
no.
thing we predicted, that tons of iron all over the surface, not so much. It's actually got one of the most iron depleted surfaces in the solar system in terms of just normal rocks, anyway. I'm not talking about icy moons.
Uh-huh.
The other really interesting thing is we figured being so close to the sun, it should probably have formed without much in the way of volatiles. And
Yeah.
had volatiles when it formed, they should have been stripped away by that intense solar
Now
bombardment.
explain volatiles.
Yeah, volatiles are any element that readily moves out from being a rock, turns into a gas, and in an airless body, that means happily leaves. We can talk about atmophiles, but when a geochemist talks about volatiles, we mean more than just the things that go into the atmosphere, which is what an atmophile is. We talk about elements like sodium, which you might be familiar from table salt. It's half of what makes up salt. Well, it turns out you heat up a rock that's got some sodium in it, it doesn't take much for that sodium to boil out of the rock and go away. So we'd expected to see that kind of stuff on Mercury where there wouldn't be much sodium, but instead there's a whole bunch of it. There's also a ton of carbon, probably in the form of graphite, and there's a ton of sulfur. And we know it's probably not elemental sulfur because it's not this beautiful multicolored, tender landscape of Io, which is covered with different polymerizations of sulfur, gives it that brilliant yellow and red and black and white all over the surface. Mercury is mostly dark grays, so we don't know why all these volatiles are there. It's a mystery. I mean, I don't know. Sometimes people get frustrated when they find out that things aren't at all what they thought they would be. I love it when we find that because it means there's something we don't know. There's more to discover here.
And you're actually hoping to begin doing research on this weird little world because this is what we as scientists do is most of us by numbers, not necessarily by fame, um, go, this is cool, study, 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 study. this is cool. And there's a write grant part in there. So it goes, this is cool. Write grant, suffer waiting for grant, get grant if you're lucky, then study it. And we, throughout our lives, transition between different areas of science as we discover new and amazing things. What is it that you're looking to learn about Mercury next?
So what I really want to understand about Mercury is, how did the thing form? So most planets in our solar system formed with a lot less volatiles and a lot higher what we call oxidation state.
Mm-hmm.
So if you've taken high school chemistry, you know that elements can have different charges. For example, iron might be 2 plus or it might be 3 plus.
And those
Or,
pluses mean how many electrons it's gotten rid of.
yes, sorry. So the more electrons it loses, the higher a positive charge we say it has, versus the more electrons it stole away from somewhere else, the more negative charge we say it has. And that's because all atoms have a nucleus with protons that have a positive charge, and the electrons on the outside of the atom are what moves to make bonds, whether they're ionic bonds like table salt or covalent bonds like most of everything that makes up your body. Um, anyway, uh, Mercury is really, really reduced compared to everything else in the solar system. That means there's just not as much oxygen on it. So things that can have a lot of different charge states tend to be in very low charge states. That's not normal for geology. It's especially not normal when you couple that with how many different volatile elements are there. So it's got a really different geology. And so there's some basic problems that we have to outline. Because we couldn't tell from orbit what the minerals are, the next best thing we can do is go to a lab and say, well, we've got some compositions of the surface. We know something about the conditions they formed under. If we stick that in a furnace in a lab, what minerals pop out of it? And then, well, okay, how plausible was that? Because we might make some crazy stuff, particularly if we end up being a little bit wrong about it.
Now, what kinds of wrong? One of the things that I like to say is the universe doesn't care about our models or what we think is true. The universe is not limited by our human creativity and is going to do whatever it feels like doing. What kinds of things do you worry about, hope for, anticipate?
So one of the things about experiments is you can't perfectly simulate anything. Um, Among other things, I don't know the exact composition on Mercury's surface. We've got a really good set of elemental abundances, but that's not the whole periodic table. And it's not super precise for every single element, at least in terms of how a geochemist would think. So if I mix that up and put in a lab, the big assumption I'm making is that I made something right.
Yes.
Miss an element that changed how the whole story would work, or I didn't inadvertently add a few extra percents that changed how that volcanic system would have evolved. Because a lot of what I do is volcanic work, so I'm thinking about how did it melt, what did it melt from, and then how did it evolve after it melted. When you talk about it evolving in a magma, so if you think about cooling down a glass of water, you've just got liquid water that cools and forms ice cubes, right?
Uh-huh.
What happens if there's some salt in that water? Are the ice cubes that form just as salty as the water it came from? Turns out the answer is no. The ice that forms has less salt in it, so you end up with ice cubes that are less salty in the middle. But because you moved some ice out of it, the water got saltier because the salt's got to stay somewhere. So the next bit of ice formed with a little more salt, and you get what we would call a zoned ice crystal, where there's more and more salt incorporated towards the edge. Well, in a volcanic system, picture it's that on steroids. It's not just one mineral, ice, it's a bunch of minerals that are forming, all of them competing for different elements or trying to exclude different elements. So the liquid keeps changing in a very complicated way. So what we're trying to figure out is, how did all of that work? And what did you
Yeah.
end up with? And what neat things should we have seen from orbit that we didn't? So
So
I worry about what composition my mixture would be. I worry about what conditions I put the furnace in, because all of these can change the answer.
now there are among us planetary scientists who have melted what they believe is material like lava and used it to do barbecues. Will you ever barbecue over your mercury simulant?
I would definitely not barbecue over my mercury simulant. So I mentioned that there's a lot of stuff that I'm calling volatiles. These are
Yeah.
things that take off of the rock as you cook it. I don't want those things in my food because sodium combined with chloride is salt, which isn't great for you. But sodium by itself is sodium metal, which is really bad for you. So I just, yeah, I don't want that in my food.
Now, I'm an astronomer, which means I have more quantum mechanics than I have chemistry of things that aren't hydrogen and helium. Um, when you're dealing with sodium and other elements, some of these things would like explode if they were in our atmosphere, and they actually act differently bizarre within the atmosphere of Mercury, but for completely different reasons. What what are the differences we see between these two worlds?
So one of the big ones is just how much oxygen there is to play around with. The more oxygen there is, the more oxidized things get, the higher a charge state most of your elements end up being. So to simulate something like Mercury, you want an environment where you've deprived it of a lot of that oxygen. The problem is we live on Earth where there's quite a bit of oxygen in our air. So you've got to do something in your experiments that moves that oxygen out of your experiment. Uh, the way I dealt with this when I was simulating Mars during my graduate work is I had a furnace that was sealed from the atmosphere, and I pumped in a nice healthy mixture of carbon dioxide and carbon monoxide, which does a great job of snatching oxygen out of the air. Actually,
Yes.
it's deadly is because the carbon monoxide will steal the oxygen from your lungs. So don't breathe it.
No,
But if you
that
seal it in a
seems
furnace,
quite
you can,
bad.
yeah, if you seal it in a furnace, you're safe from it, it's safe from you, and it can change how much oxygen is around your sample. Now, mercury is way too reducing to do that, so I've got to do a different setup, and that's way complicated to describe. But
Okay.
you do other things to pull the oxygen out of it.
So, have you ever looked at Mercury in SOHO data or SDO data?
Nope.
So, one of my favorite things about solar data is our solar system has a ton of what are called sun grazing comets. So, on a regular basis, small objects, by which I mean things potentially the size of houses and buildings, and sometimes bigger than that, city block sized, will plunge themselves into the sun and die a fiery death. Occasionally, they make it back around. They graze the sun instead of going into the sun, which is a good thing. And the result is that we get to see in data that is designed to observe the solar surface all these little comets with all their big bright tails plunging in. And one thing that deeply confused me is you can see Mercury passing behind or sometimes in front of the sun in this data, and it has a tail. Can you tell us more?
I'm not an expert in this for sure, but one of the neat consequences of Mercury having a lot of these things I'm calling volatiles is that the sun does keep baking them off the surface. And so you get very, very thin amounts of this coming off of the planet, making what we refer to as an exosphere. We're really just trying to make sure that no one confuses this with an atmosphere because it is really, really thin, very, very low pressure. But for the right kind of telescopic observation, you should be able to see this chemistry coming off of Mercury. And it should look like a tail because it should be streaking away from the sun because it's the solar wind that's blowing it off the surface.
And so far, all we've talked about with Mercury is its hellscape, the the fact that the sunlight is powerful enough that sodium is departing the planet, calcium is departing the planet. But as hot as the world is, as close to the sun as it is, it nonetheless has water.
Yep.
How?
For a full answer on that, you need to talk to someone who knows more. But one of the things that happens is there's some craters that are deep enough that the sunlight never makes it inside of the crater. We actually see the same thing on the moon. We call these permanently shadowed craters. And it really is just usually that they're high enough in latitude, so up near the poles, and they're fairly deep divots that have been dug out by these meteorites impacting the surface. And so they're cold traps. So any little bits of hydrogen wandering around the surface are going to find their way there, find some oxygen to hang out with, and make a little bit of tiny little droplet of water, which will then freeze because it's really cold where the sun doesn't shine.
This is true. This is true. And I have to admit, astronomers and planetary scientists both get far too much pleasure saying it's really cold where the sun don't shine.
It's true.
Currently, we've had the Messenger mission go most recently to Mercury. The Bepi-Colombo mission is slowly, painfully slowly on its way there.
Yep.
Uh, we also have ways of observing this world not as effectively in optical light, but in other wavelengths from Earth.
Mhm.
What are the different ways that we can study this little world?
So remember, I'm not an astronomer. I
I
study
know.
rocks.
Yes.
But my understanding is that pretty much any wavelength of light, now, this doesn't just mean optical, it also means infrared or X ray or gamma ray for that matter. Um, Anything that you can pinpoint as coming from Mercury, you can still study it. One of the problems with Mercury is it's small and it's close to the sun, and the sun is an excellent light source. And so it's really hard to tease out what signal is coming from Mercury versus what signal is coming from the sun. And you can picture the idea of trying to see something really small up against a bright halogen lamp aimed right at your face. You can't see the small thing. It's a little drowned out by the brilliance of the lamp that you kind of wish you could turn off so you could see the small thing. That's the problem with studying Mercury from the Earth, and one of the reasons why we want to send spacecraft there. As you get a little further out from the sun's glare, it's easier and easier, particularly when they have orbits further away from the Earth, so that you can just point away from the sun. But again, I'm not an astronomer, so my answer here isn't very nuanced and hopefully not entirely factually wrong.
As far as I know, you got everything right.
Excellent.
Now, I mentioned how slowly and painfully the Bepi-Colombo mission is getting to Mercury. And this is a spacecraft that they named it in 1999. And it's still not there.
Yep. It actually recently did a gravity assist around Venus.
Yes. And and why is it so hard to get to Mercury?
Well, the short answer is conservation of angular momentum. Yay, science jargon. So people think of going towards the sun as though it were falling downhill, which we think of as really easy because it's just going down the gravitational gradient. The problem is in space you don't have ground. So anytime you want to change where you are in orbit, it takes a lot of energy to do it. Now, we can do this ourselves with rocket engines. Problem is, Every bit of mass you put in your engine is another bit of mass you don't get for your science payload. So there's a huge trade-off between how much fuel did I send up to get this thing there fast versus what can I do when I get there? That is, how much science payload do I have for this? And remember, you've also got a constant mass for your energy system. In the inner solar system, that's often solar panels. In the outer solar system, it's often nuclear. You've also got your computer. You've got, particularly relevant going to Mercury, you've got your cooling system so that your space
Yes.
doesn't overheat, or your heating system so it doesn't freeze. There's all this extra mass that you have to move along. And so it's this trade off of, well, if I go really slowly and I make the best use of gravitational assist I can take a lot more science versus I can take almost no science if I get there in a time scale that seems a lot more reasonable. This is particularly true if you want to orbit the planet, because getting into orbit takes a whole extra amount of energy and precision because you're trying to lose a lot of energy once you finally get there. A flyby is a lot faster, but you only get one look, at most at half the planet.
And that is more than a little frustrating.
Oh, yes.
And that's where we were for the longest time. We had early Mariner data, and then we waited decades before we finally sent Messenger on its way. Now,
Yep.
Astro YYZ is asking, I'm curious, Dr. Castle, when studying volcanoes on other worlds, if you study earthly volcanoes too.
I would actually love to. The problem is I've always been doing planetary science research, and not that many planetary scientists also have projects on the Earth. That said, I read a lot of the literature about how volcanoes work on the Earth because the Earth is the best studied example. We know a whole lot more about any volcano on Earth than we do about any volcano anywhere else. So if we don't know how it works here, it's really hard to figure out how it works there. Sorry, that's a lot of words to say.
No, it's one of the things that I particularly delight in is the random, unexpected statements that come out of planetary scientists' mouths when they treat the Earth like a planet. Uh,
Yes.
I was listening to a colleague of ours discussing a volcano he'd recently visited that had characteristics similar to Martian volcanoes, and it happened to be in Idaho. I wasn't expecting Idaho to come up in conversation while discussing things that are like they are on Mars, but it turns out there are extinct Mars like volcanoes in Idaho.
Yep.
And there are crazy colleagues that we have that will actually go out walking on active volcanoes, getting various gas samples and other such samples, and hopefully staying alive in the process. Planetary science is actually safer when you're studying other planets. Um, if you could have any data as easily from another world as you have, or from Mercury, because we're talking about Mercury right now. If you could sample anything on Mercury as readily as you sample things here on Earth, or other people that we work with go out and sample them on Earth, what kinds of samples would you want to compare with what you're doing in the lab?
So a lot of planetary science is driven by astrobiology right now. It's the hunt for life, trying to figure out, could life exist somewhere else? Does life exist somewhere else? Could life have originated somewhere else? And a lot of that's trying to just get at the question of, how rare is life? And there's a famous equation called the Drake equation that tries to calculate what are the odds of us ever encountering another civilization, something else that evolved to think and be rational and communicate. And we seem to be just keep trying to knock off the different variables of that. How many stars are there? How many of those stars form planets? How many of those planets could plausibly support life? How many of them actually do support life? How much of that life evolves past very primitive forms to develop rational thought? And so, one of the questions we're trying to get to is life on Earth unique? Or did
Yeah.
it form everywhere we look? I mean, we've recently seen headlines of there may be life on Venus. For a long time, we've debated about, is Mars a habitable environment? We've seen evidence of rivers and streams, which is a lot of, the kind of environments that we expect to find life on Earth. We talk about Europa, we talk about Enceladus, we talk about Titan. Could there be life on Mercury? Could there have been life on Mercury? No idea.
And as we continue through our 36 hours of streaming here on twitch.tv/CosmoQuestX and on Now Media Radio going out across the airwaves and through Apple TV and Roku, as we go out, we're going to have guest after guest for the next 36 hours. And coming up in hour 7, which is the hour after next, so an hour and a half from now, we're going to be joined by Doctors Phil Plait and Patricia Craig, who are going to be talking about our exploration and understanding of Venus. So don't go anywhere. Take bio breaks as needed, people. Don't go anywhere. Stay with us as the science continues. Now, this 36 hours of streaming is dedicated to, well, first of all, we are building a full-scale model of the solar system in Minecraft, and we will be going to the mines on the 49s. So stay with us. We will be revisiting what's going on in about 20 minutes. But beyond that, we are here to fundraise, to keep CosmoQuest going far into the future. Science takes money, science communications takes money. Everything that we do, Astronomy Cast, The Daily Space, 365 Days of Astronomy, all the citizen science, we marked more than 14 million things on the surface of Bennu to help find the Nightingale crater where the mission grabbed an overly large sample earlier this week. It takes money, and we provide all of our part-time staff benefits when they need them. Your donations, which are tax deductible where allowed by law, allow us to do what we can do. We are currently up to $2,083 on our $36,000 goal for the weekend. Times are tough. We don't know if we'll make our goal. It costs us about $150,000 per year to do what we do. If you're one of these people that looks at your portfolio each month and isn't feeling the hurt of COVID too badly, please consider donating. What you do allows us to do everything we do. And all of you are welcome. And we have giveaways for everyone watching. If you can get to the twitch.tv/CosmoQuestX chat, folks are putting up instructions. The next raffle of a giveaway starts in 10 minutes. The next thing that we are giving away is going to be coasters that are embroidered with planets, where you're going to be given, I believe, a choice of colors. So go check it out and go win something awesome. So Nick, you are entering Minecraft, and I'm going to put you on the spot a minute. Which worlds are you going to be focused on building?
That's a good question. I mean, I like to help out where I can. I actually really want to tweak the Mars globe because I want to see some of the recognizable features, some of the things that get my heart going when I see them from distance. But it's hard because on the scale of the solar system, Mars is really small. I mean, it's tiny compared to the Earth. It's really tiny compared to places like Jupiter and Saturn that are going to take so much effort to try and map out the whole way. So I want to go there and I want to play with it, but we'll see what happens. On our
So
earlier mission, I also mentioned a great library that gives information about the solar system. So I might be a little distracted trying to build a large Grecian-style temple with stained glass windows that look like different parts of the solar system.
that is kind of amazing. That is kind
Anyone who
of
wants to help is
very
welcome. Just
amazing.
come on by and be enthusiastic.
um, so I can't wait to see how that comes out.
We both.
Um, going going back to Mercury, the image behind you is not a real color image.
That's true.
Mercury is in reality various shades of earth tone. I don't know a better way to put it.
It's shades of gray.
Yeah. So,
Okay,
how do we take the messenger data and tease out dramatic looking images like what you're showing?
so this is what's referred to as a color stretch. There's a lot of value in looking at an image in real color because it gives you an appreciation for what we see. But oftentimes, when we want to do science, we need to do better than our eyeballs can in terms of saying, well, what of all is on the surface? So, this is actually a compositional based color stretch where they're looking at what are the different basic terrains, that is, the different kinds of geology across the surface. Now, I will admit, I'm still pretty new with Mercury, so I forget what the colors actually represent. But it highlights there are different portions of Mercury with very different chemistry in what we can see. I actually love this image because it, you know, really oftentimes when I see just a snapshot picture of Mercury, I'm like, that's a weird view of the moon. Oh, that's because
Yeah.
it's not the moon. That's because to your eye, they're both gray, saturated with craters, with streaks from some of the big craters.
And I have to give a big shout out of thanks to Marcel Jean, who just donated $205.80. Thank you so much. Thank you so much. Um, keep going, guys. Keep going. Now, one of the things I particularly love about the image behind you is when asteroids and other impactors careen into the surface of Mercury, they dig down and pull out materials that they then splatter everywhere. And there are truly amazing splatters everywhere. Um, can you talk at all about that?
I'm not quite sure what you want to hear about it. There's some really big impacts there that make multi ring basins. There's, yeah, I'm not entirely sure what to say.
Okay, so what's really cool about Mercury, if you can tilt to the side a bit, so there's this like spider web of rays going out from the craters. You're welcome to go back to sitting normal again. And that's all deeper material from further down under the surface of Mercury that has been excavated. And it's just like if you, I don't recommend doing this, people, but should you have a reason to, if you blow up something outside or witness it in a movie or TV, you'll see material that gets sprayed out in all directions. And asteroid impacts essentially do that. And with Mercury, when they spray that material out, it can actually go all the way around the world, changing the surface composition to include internal composition in the messiest of ways. The messiest of ways.
Now, what's interesting is we still don't have spectroscopy that tells us what the different compositions are in terms of minerals. We do have things that tell us what the elements are, but they tend to have big enough footprints, it's really hard to tell the difference between stuff dug up from deep down, like you were talking about in impacts,
Mm-hmm.
and stuff that was sitting around the surface. We also know there's a process called space weathering, which should be particularly vigorous on Mercury, being so close to the sun. And what this is it's when radiation, both in terms of solar wind particles, ions like hydrogen and helium, and in terms of just intense light, hits the surface, it changes what that surface looks like. And one of the things that a number of people are trying to study is, well, how so? What does this really look like for Mercury? But again, there's a problem. You need to not just know the radiation environment, you need to know what materials it's hitting, which means
Yes.
not just what elements are there, but what minerals.
So you have this frustrating duty to figure out in the lab how to recreate something we can't study in detail.
We actually could, but what we would need to do is not just orbit Mercury, we need to land on Mercury. And then not just land, we need to drill a hole in the surface, collect the powder, and stick it in an X ray diffractometer. Now, this sounds crazy, but it's exactly what we do in the Mars Science Laboratory mission with the CheMin instrument. We drill a hole in the ground, collect the powder, and then stick it in an X ray diffraction device that tells us what the mineralogy is. I would love to see a lander on Mercury do the same thing so we can figure out, are my lab experiments reasonable? Like, what really is the mineralogy there? Only way to find out is to go and figure that out.
And are there any plans to land on Mercury?
I'm sure some people have plans for that. I've even talked to a few who are also enthusiastic about it, but to my knowledge, there's no official program call for a lander on Mercury yet. Um, I'm hoping there will be someday, but it's also going to be a really long term thing because when we land, for example, on Mars, we make use of the atmosphere to slow ourselves down so we can get to the ground using parachutes, only using rockets at the end if we need to slow down a really big rover like MSL or the new Perseverance rover that's headed that way. On Mercury, we don't have that. If we try to slow down in the atmosphere, we'll hit the surface from orbital speed. So we've got to have a whole bunch of rockets that can slow us down and land on the surface without human intervention because it's a long enough time delay. We can't control that either.
And this is the kind of thing where the fact that Mercury and the moon, other than the temperature profile, are reasonably, I feel comfortable saying reasonably similar worlds.
Yeah, there's a lot of similarities, particularly in terms of the engineering difficulty in getting there. And landing on the moon has a lot of the same problems that landing on the Venus would have. Venus, sorry, Mercury. I study too many planets. It's a lot of the same problems landing on Mercury would, but with the added complication of being so much further away that if anything goes wrong, we won't find out about it until it's all over.
Yeah. And and that we've lost a lot of spacecraft to Mars over the years.
Oh, yes.
But getting to Mars is 6 months. Getting to Mercury is years.
Yep.
And so you don't get a second chance in one researcher's lifetime to get that right.
Yeah.
And that just, this is where you have to remember always that planetary science is all about the delayed gratification. If you want to know something now, you'd better hope somebody already took the data you need,
Yeah. Or go into a different field entirely.
or
I
just
mean,
study Earth.
yeah, that one helps too. I mean, you talk about the long lifespan of science missions. There's years where a few people that are just really fascinated by the science are persuading the community there are great questions that can only be answered with a spacecraft. Then years competing for what that spacecraft would look like, and then finalizing the design. Then years of building it. Then after launch, if that's all gone well, years for it to get there. It takes a lot of patience.
Yeah, and you don't even bring up the years that go into just trying to get your spacecraft funded.
There's that too.
And so this is where the elders of our field are really designing and building the future of our field for
Yes.
people who are probably still in high school or younger or younger.
Actually, one of the coolest things about some of the active missions right now, like the Curiosity mission, MSL, I keep talking about, um, that was launched from the Earth while I was in the middle of doing my master's degree. But I still get to be a part of the mission because the senior people carefully carved out spaces for early career scientists that hadn't even gotten there yet, had no idea who they would be, to come in and take active roles with the mission so that they could train the next generation in what mission science looks like. And it wouldn't just be the collection of people that had spent most of their careers making it happen working with the mission.
Yeah. Sorry, we have things going on in the background with schedule changes that keep pulling me in. Um, so we're almost out of time. You're only at the beginning of your career, which is a very strange juxtapositioning.
Isn't it, though?
Um, what what do you look forward to most with what's currently planned in exploration in the coming years?
I can't name any particular thing. There's just too much that's exciting. I once heard it described that scientists are like cats. We wander around, we find something shiny and interesting, it's fascinating. In science, that's usually a question that we don't know the answer to. And like cats, finding something interesting, sometimes it's just as good to find the next shiny thing as it is to figure out what was going on with that in the first place. I'm excited by the variety of what's going on in the space program. We've got missions to Mars. There's a plan to send missions to Europa. There's a push to try and get something to Titan or Enceladus, or better still, both. There's even a mission concept to go explore Triton, a moon of Neptune, which we don't know
Is
much.
bigger than Pluto.
Yeah, it's huge, it's really cold, and it's fascinating. And we know next to nothing because we've only ever had one spacecraft fly by the planetary system it's in. On top of that, there's talk about going back to Venus. There's a Mercury mission en route right now. There's just so much cool science going on. That's what I look forward to is the variety.
And with all the current missions being planned, we wish everyone the best of luck trying to get everything done, launched into space. And one of the things that really is exciting to me is how much the launch capacity of our rockets is looking to increase in the coming years as we start building mega rockets once again, things that can launch giant telescopes in one go. Um, it's it's going to be amazing, and you're going to be here for a lot of it, helping to shape what we discover. And I'm glad that you're one of our colleagues.
Well, thank you.
So, is there anything in particular that you'd advise people to keep an eye on with you?
With me,
Well,
uh,
with you or alongside you, if there's like Beppo Colombo and things like that. What are you following that others might want to follow too?
uh, again, I'm not entirely sure how to answer that because there's just so many things. One of the critiques of me is my greatest strength is also my greatest weakness. I'm never lacking for ideas. So, honestly, just keep watching what's going on with space, whether you're interested in human exploration and what's going on with SpaceX or Boeing's new spacecraft they're developing, or you're interested in robotic missions and what's being planned. And with more and more different countries around the world getting involved in the space business, I mean, just keep watching something, be enthusiastic, dive in.
And this is what we're here to support here at CosmoQuest. Um, we are here to make it easy for all of you to follow what's going on with our daily space show, shown both on twitch.tv/CosmoQuestX and now Media Radio, and with all the ways that we work to engage people. So if, like Nick, you don't know where to start, we'll bring it to you every day. So just tune in, give us a follow. We've got you. And thank you for having us this past hour, Nick. I know that this is a time when you're involved in grant writing and everything else, and you just also want to go build pretty stuff in Minecraft. Thank you also for the donation, Stephen. Thank you for the donation. Um, And thank you for the bits, Road Rash. Thank you. Um, so I'm gonna release you to go back to all the awesome things you have going on, and we're gonna go to the mines on the 49s. So thank you, Nick, and I will see more of you throughout our adventures this week.
Sounds great.
Okay,
Well,
bye
take care,
bye.
everyone.
All right, we are at the Overworld Welcome Center. Um, who do we have guiding us?
We have Kerbal 01.
Hi, Kerbal. Give us a tour.
Here's the Overworld Welcome Center, and as you enter through the large entranceway, you can take a left, right, and get into the Project Explanation room, and you can read a book about what we're doing here. In the other room is a brief explanation of how Minecraft works. And over here is how you get into space. But if you go outside, there's a garden with a bunch of flowers. And if we fly over here, there's a launch gantry power tower pad of some sort. And the beginnings of a Apollo lunar lander over here. And what looks like a large telescope over here. I don't know if anything's in it. There does appear to be something in it. Neat. Looks like someone's making a space shuttle. And I'm not sure what this is. But let's go to space and see what's going on up there. This is the core of the sun. And it's big, because the sun is big. We're only just now getting to the outside of the core of the sun. Yes, I like all of the detail. And it just continues that way for a long time. And so now we're going back to the core of the sun so we can go to Mercury and see what's going on over there. This is the welcome center for the core of the sun. And I believe Miss Brick Kitten built this out of quartz, all the different kinds of quartz and blackstone, and it's where you can go directly to all the different planets, because flying to all the different planets would take a really long time. So let's now go to Mercury. And here we're seeing Keeper of Maps build Mercury. And he's getting pretty far along. Here's the Mercury palette. It's two different kinds of dead coral, and I believe I don't actually know what that is. It might be wool. It's andesite and light gray wool and netherrack. Keep it up, keeper. And over on Venus, here's a palette, and people are... I don't see anyone actually building on it, but they've got a good portion of it done. Using a variety of the colors in the palette. And as you can see, Venus is 24 blocks in diameter. And after the solid surface is done, they will use the glass to make an atmosphere. And over on Earth, we got a North Pole so far. But here's the palette. It's blue concrete, light blue concrete, brown, two kinds of wool. That's quite the variety. And we can go to the moon, which looks to be done or almost done. And it's made out of a bunch of dead coral because it has that cratery look. Ooh, and this appears to be a Easter egg, which is a small version of the Israel lunar lander that almost made it to the surface. I don't know the name. Well, I know the name, but I can't pronounce it. Bereshit. And going back to the core of the sun. Let's go to Mars. Mars looks very well along. I can hardly see any of the glass, and looks like we have another Easter egg. Mark Watney colonized this planet. There's potatoes growing on a little patch of dirt and a campfire. That's pretty cool. And there's the palette. We got half slabs. I don't think any of the other pellets have half slabs. That's what lets you get more detail. And the asteroid staging platform is coming soon, so let's go over to Jupiter and see who's working there. Ambius is working. And Pixel Riffs. And Jupiter is pretty big. It's the entire world's height. It's 256 blocks. And here you can see the amazing Great Red Spot. And we got the start of the rest. That's looking pretty cool. And now we're going to Saturn. Which I was, before this, I was working on Saturn. So I'm trying to make the light colored patch, and this extends all the way around the planet. Mostly. Gonna make it bigger. And here are the rings of Saturn. They're light gray concrete. got lots of dots. I assume those are moons. And Titan is also a thing, so let's go to Titan. And there's Titan. The color palette is orange stained glass, yellow concrete powder, and soul soil, which is for all the different surface things. Because Titan has an atmosphere. It looks like it's orange from Earth, so orange stained glass. And let me see what the dark dunes are. The soul soil. And just the regular surface is the yellow concrete. So that looks like it's pretty well coming along. Yeah. And now I'm gonna hand things back to Pamela.
That was amazing, Kerbal. Thank you so much for joining us and taking us on that tour of the solar system.